The purpose of this project is to develop a sustainable hollow concrete brick by replacing 5% of natural sand with recycled material, which is rice bran. The main idea is to reduce the dependence of natural sand, as excessive sand mining can harm the environment. At the same time, using rice bran helps recycle agriculture waste instead of disposing of it. By using this sustainable material, we aim to reduce construction waste, conserve natural resources, and produce a hollow brick that still has acceptable physical properties and compressive strength for construction applications. There are 4 main objectives in this project. The first objective is to produce a sustainable hollow concrete brick using rice bran as a partial replacement for natural sand. The second objective is to reduce the consumption of natural sand by utilizing agriculture waste. The third objective is to evaluate the physical properties such as dimensions, weight, and density. Finally, the compressive strength of the brick is determined to evaluate whether the replacement material affects the overall performance of the brick. Concrete is one of the most commonly used construction materials because it is strong, durable, and economical. However, producing concrete requires a large amount of natural sand, and excessive sand mining can harm the environment. In this project, we use rice bran as a partial replacement for natural sand. Rice bran is an agriculture byproduct that is produced during the rice milling process. Instead of being discarded as waste, it can be reused as a sustainable construction material. We replace 5% of the natural sand with rice bran to study its effect on the physical properties and compressive strength of hollow concrete bricks. This approach helps reduce waste, decrease the use of natural resources, and support sustainable construction.
First, we begin with material preparation. We weigh all our raw materials according to the specific mix design. This includes cement, coarse aggregate, gravel, fine aggregate, sand, water, and our innovative addition, rice bran, which serves as a 5% replacement for sand. Next is the mixing process, which consists of 2 phases. We start with dry mixing, where the cement and sand, gravel, and rice bran are soldered together until the mixture reaches a completely homogeneous state. Then we move to wet mixing, adding water gradually to ensure proper consistency and workability while preventing segregation of the materials. After achieving the right mix, we proceed to fabrication and curing. The concrete mixture is poured into the hollow brick mold in layers and compacted thoroughly to eliminate any air voids. Once molded, the whole brick is placed into a water tank for curing. This step is crucial to support the semi-hydration process, allowing the bricks to gain their maximum structural strength. Finally, we conduct the compressive strength. After the curing period, the bricks are dry and placed into the laboratory compression. Load is applied continuously until the brick falls, allowing us to record the ultimate load in kilonewtons and evaluate the structural performance of our sustainable bridge.
Based on the experimental results, the fabricated brick successfully meet the required dimension of 220 mm by 100 mm by 70 mm. The measured weight of the brick was 2.671 kilograms. The brick surface appeared smooth and no measure were observed. The calculated density and compressive strength demonstrate that replacing 5% of natural sand with rice bran still produce a brick with acceptable physical properties and structural performance. Next, based on our experiment, replacing 5% of natural sand with rice bran produced a hollow concrete brick with acceptable quality. The brick maintained its standard dimensions and had a good surface condition without major cracks or defects after curing. The compressive strength showed that the brick was still able to withstand the applied load, which means that a small amount of rice bran can be used without significantly reducing its performance. In addition, using rice brans helps reduce agricultural waste and decreases the demand of natural sand. This makes the brick more environmentally friendly and supports sustainable construction practices. However, if too much rice bran is used, the brick may become weaker because rice bran has lower strength than natural sand. Therefore, the replacement percentage should be carefully controlled to achieve a balance between sustainability and mechanical performance. Overall, 5% rice bran can be considered a suitable partial replacement for natural sand in hollow concrete brick production.
In conclusion, this project successfully produced a sustainable hollow concrete bridge by replacing 5% of natural sand with rice bran. The fabricated bridge achieved the required dimension and demonstrated acceptable physical properties and compressive strength, indicating that a small amount of rice bran can be used without significantly affecting brick performance. The project also highlighted the importance of utilizing agricultural waste to reduce the consumption of natural resources and support sustainable construction practice. However, this study has several limitations. Only one replacement percentage, 5%, was investigated, and the evaluation was limited to basic laboratory tests. Future studies should investigate different replacement percentage, perform additional durability tests such as water absorption and long-term strength, and compare the performance with conventional concrete bridge to determine the optimal amount of rice bran for practical construction applications.
Throughout this project, we gained valuable knowledge about sustainable construction materials and the importance of environmental protection in civil engineering. We also improve our laboratory skills by learning the correct procedures for material preparation, concrete mixing, brick fabrication, curing, and compressive strength testing. In addition, this project strengthened our teamwork, communication, and technical reporting skills, which will be beneficial for our future careers as civil engineers.